My name is Sam Edwards. I go online as Handstand Sam. I'm not going to do a handstand today, but I have a bunch of handstands photos. Maybe at the end, once the video is cut off, I'll try. But yeah, I'm a lead Android engineer at Capital One, and today I'm going to be talking about, as a Kotlin developer, wanting to do SQL on Android and what that looks like. So why are we talking about this today? Like I said, I've been using Kotlin for over 2 years, and I really love it. And I came to a point where I needed to evaluate database ORMs. Like, I'd used databases a little bit, but I didn't know that much myself, so I wanted to go in and see what was available at this time. So I submitted this talk to droidCon Boston back in February, and it got accepted, and it was only 2 months later until they gave the talk. So I went a little overboard and kind of dove in heads first to try to figure out like what there is, and had a time crunch. So this is kind of like the experimentation of Kotlin and databases and us going in and figuring it out. And the caveat here is I have no idea what I'm doing. Like I said, I really didn't know much about SQL on Android and what to do. I just knew I like Kotlin. There's these new databases, I wanted to do a database. What library is really going to be the best experience for me? So just wanted to kind of talk about whenever you're learning something. So coding brings confidence. I say this because if you don't know anything, you're like, oh, what's going on? What am I doing? If you actually sit down, you try to bang through and write as much code as you can, you finally say, oh, I got this working, you commit it. You get something else working, you commit it. And that brings a lot of confidence. So this is right before I did that talk at droidCon Boston, so I was a little bit more confident. But then last week, I shared this content. So I just put a blog post out about SqlDelight, and actually sharing that content and putting it in a form that people can read and like they go through and they like learn about it takes a lot of effort. So once you do that, I feel like I'm an expert at this level of it. But I don't know a lot about the advanced stuff. But I think you're going to learn a lot about this talk, and I hope that it'll give you some insights into some libraries. These are some slides from a keynote I did a few years ago called How to Do a Handstand, and it's about how it was an analogy between how you learn things in the physical world and in the digital world. But in both of those, you end up learning, right? So if you're this expert in the orange and a beginner's there in the blue, as you grow and you learn more content, it's good to share it, because if you do that, you can level up the person behind you. And it's important to do it as you learn, because like as this talk goes, I wasn't like the most experienced with this, but I'm sharing it and I'm finding that a lot of people are learning from that because they're coming from the shoes that I was standing in. The good news is those people can learn and get up to your level and then hopefully surpass you, and then you can learn from them. So it's kind of just a cycle. That's kind of why I do these talks, and just a reminder there. So let's get going. So today, this is kind of going to be a pair programming experience. This is going to be, we're looking at the code together, you're over my shoulder. Half of this is like in Android Studio. So let's look at it from that perspective, and we'll even be kind of like a team going through and having a problem that we want to go ahead and have a solution for. Today we're going to be using this shopping app that I have on GitHub. So if we check that out, it is this open source app. It's available out there. Feel free to grab it. I basically use it to do any of my kind of playing around with new libraries. And inside of here, you can just kind of go through categories. You can get some apples, add it to your cart, add or remove. Nothing too fancy, but it gives you enough that you can like have a playground to do some of this stuff. So so this is the app we'll be working on. One thing you'll notice though is if I go ahead and I force close the app and then I open it again, I don't have anything in my shopping cart. So this is what this talk is going to be about. How do we keep stuff in our shopping cart? So yeah, our task at hand is we want to make the shopping cart functionality persist between sessions, because it should make us tons of money, right? We're this awesome startup. We're going to make so much money, but like our product folks and business folks have said, hey, if we can remember what they wanted last time and they come back, we can increase our sales a lot. And currently our database our code base has no database. And so we want to go ahead and figure out how we can persist that between sessions. So the way I started out with this and the way it already works is an in-memory version. So I do have a way of storing this data and accessing the data. And what's nice about this is anytime you have an in-memory version, you can test the functionality and you can stub it out, but you don't have to know what's behind that data layer. And that's what's important about like interfaces and good software engineering practices, is you can just have a stub or anything there and you can put something behind it whenever you want to. and that's why you need dependency injection as well. So we want to interface to allow swapping of our database implementations or whatever our data store may be. And ideally, you want to go ahead and create a reactive stream that can be subscribed to for updates, because that little thing we had in our shopping cart that is in the very top right corner, as we add items, we want it to go ahead and update reactively. Or once we're in here, you see 4 items in the cart. As I change that, I just want a stream of updates so that I can go ahead and make sure all the UI is updated and everything is in sync. So, all right. So we're going to check out some code now, and whenever you see something like this, we're going to hop into the code. And this is all code available on that open source project. So hop in here. So this is our shopping cart DAO. So this is just something that I put in as an interface behind all these data sources. So at this point, there's going to be an in-memory version right behind it that we're going to check out. So if we look at all the implementations, I guess we'll kind of cheat and go ahead. Let's not do that yet. So we'll look at the in-memory version of this. But as you see, there's just a few things on here. There's a select all stream, which is that channel of reactive updates. The ability to find an item by a label. The ability to upsert, which is to insert or update an object in the database, remove, and empty. If we go ahead and open this in-memory version, you'll see it's actually just backed by a mutable map. It's a string, which is the key in this case, and then the item with a quantity. And so in here, we went ahead and I messed up something here, it looks like. Yeah, we went ahead and implemented this interface so that we have the insert, update, find by label, and so forth. All right, sweet. So moving on. All right, so I did a lot of Googling around, and I ran into these 2 libraries, Room and SqlDelight. So today is going to be mostly looking into those. But the question you want to ask yourself whenever you're developing a project is, do you actually need that feature that you think you do, right? You're going to learn a lot about all these cool new libraries here today. But do you actually need to use that? Is it something that fits your project? So think about this, and if we thought about our situation now, we just want to persist a shopping cart on disk. So we could do it a few ways. We could put it in shared preferences. Many people have probably done this before. You could store it in the local JSON file. I'm not saying either of these are good solutions, but they're solutions. Or you could store it on the server. And if you think about it, this might be the best solution, but it requires more work, right? You're doing this because you can track things on the back end. If a price updates, you could get that easily and stuff like that. But I think at the end of the day, a database here is going to be a good solution. Whenever you use a database, though, with great power comes great responsibility. You're responsible for every single byte of data that you persist. This is really the same with anything that you're writing in shared preferences or in databases. But with databases, it's usually pretty complex data. So any writes that you actually make to disk, you have to be able to support during upgrades, unless this data can be kind of blown away and recreated at any point in time. Migrations are something there for SQL that can be used in order, if you change your data structure. Let's say you add a price column, because I don't have that now. You could go ahead and add that data later. So reactive stream for UI updates, this could be its own talk, and I'm kind of going to glance over this right now, because in my talk, it's more going to be evaluating these databases and not necessarily the reactive manner. This was just a requirement that I had to have this. So the reason why we had it is we wanted that shopping cart to reflect the most recent changes. We needed, and some of the options could be just a listener or a callback to the data store, right? This is the easiest way to kind of say what changed. In RxJava, you have flowables. In Android architecture components, you have live data. In Kotlin Coroutines, you have channels or flow. So you have all these different options. In this talk, I'm not really going into it, but I know the new hotness is flow. In the latest alpha or beta of Room, they have support for flow. And I think in the snapshot of SqlDelight, they have support for flow. So those are all coming out. Let's check out our shopping cart then. And this is actually the interface that our application will interact with. All right, so this is a wrapper for that shopping cart DAO that we talked about a while ago, which is kind of just describing this data source. So if we look at shopping cart, it takes in that DAO, but then it's going to implement all the business logic that we have on top of it. So when you want to increment an item, it's going to go through, find that item, increment it by 1, and save it, or delete it, and so forth. But it's just a way that we have a little bit of business logic on top of that. And I love testing. I've been burned so many times that I realize that testing is really important, and therefore I love testing. I think everybody gets to that point in their career at some point. But unit tests allow you to validate your current implementation, and you give us confidence in your code. Programming a lot is just confidence, right? You've tackled enough problems, you know you can figure out something. So coding brings confidence, sharing brings confidence. So let's look at this test. As you can see, this test result here for this in-memory version is passed in 200 milliseconds, which is really fast, but that's because it's in memory. So in here, I'm using kind of the robot pattern for unit tests. In our app, we call it test delegates. It's basically the same thing. We can have this nice fluid way of describing our tests and what we want to do, and then doing assertions on them. So I can I can decrement an item in the cart, assert that it's there. But these tests that I ended up doing are just 3 simple tests, like a happy path inserting stuff, or removing an item that's not there to test an error scenario, and then adding 300 items. So there's nothing much to this, just to say that this is a test that you could write, and so that we could get we'll test each library with this same logic. So our technical requirements from our team when we're going to implement this database feature is to use a stable, proven version of this library. We don't want to break incremental builds. I can't say this enough. It's something that's kind of really bitten us as a team previously, so we've been very, very diligent to not break incremental builds. So yeah, that's a big requirement. And that's just because build times, if you know when you hit the play button in Android Studio, if it takes more than 15 seconds, it really sucks to wait there. We want to publish our changes reactively, and we want to make sure we have clean separation using modules. So highly recommend using a lot of modules in your app to kind of separate out interfaces, implementations, and be able to switch things around. I have a talk about dependency injection. I just did at Android Summit 2 weeks ago, and that kind of enables this sort of stuff. So we have 3 modules in this app. One is Shopping Cart, which just is like the interface and the in-memory version. Then we have a Shopping Cart SqlDelight, which is the SqlDelight implementation, and then Shopping Cart Room, which is that implementation. And the reason why I did this here is you could just take one of these and throw it away, and you would never need it again. And since I was experimenting, I wanted a way so that somebody could clearly see, this is how I implement Room, this is how I do SqlDelight, or anything else. So if we actually look back in our code base, you'll see here there's these 3 modules. And I don't know why this code got read, so I kind of want to make it so it's not anymore. See? Pair programming, right? This is good. All right, this will tell me. Thank you, Git. So we're just going to say revert changes. Gabbing cart DAO. I like it. Thank you very much. Cool. All right, so we have those 3 different modules. That's a great way of separating those concerns and being able to swap things out. So we're finally here. You came to Select Star from Kotlin because you wanted to learn about databases. So let's go through, get our boxing gloves on, and go. So we do have Room and SqlDelight. They're both great libraries, but let's go deep into Room first. Then we'll do SqlDelight and put a little stuff in the middle. So Room is a library from Google. It's a Jetpack library. It has amazing online documentation. With Jetpack and Google, they really take a lot of time to say, somebody that's new to Android or been there a long time, how do I make something that's easy to onboard and powerful and works in prod? And they also put documentation behind it, and they just have a lot of money there. So they're doing that, and they do a great job. It is proven out, so people have been using it for a long time, and it's great. The thing I didn't like is it used code generation via annotation processing. So if you've seen capped in your builds, it takes the annotation that you have in code, and then when you run the build, it goes ahead and runs the annotation processor and generates code from that. And that actually breaks incremental builds. And then you might say, oh, well, it doesn't because they have a new feature, but by default, that's off right now until it's stable. And I don't know. When I evaluated this, it did not have incremental build support at all. I was kind of, they didn't have a lot of releases, but they actually did just have one in June that came out. And they have one that just came out actually last Friday, and that one had support for Flow. All right, Room. So if you're a developer and you want to go ahead and set up Room, then you need to add 2 dependencies. One is your implementation dependency, which is what you're going to use when your app runs. And the other one is that annotation processing dependency. So if we jump in and over in our build.gradle for the Room, we can see we have two things. So we have our API, or it could be implementation, for the Android persistence library, and then we have the capped for the other one. So I'm using build source here. Oops. There we go. But anyway, you could peek in here. It's basically the Android X Room runtime and the compiler that you're bringing in. Next, we have, so let's see what code we have to write. So there's three things really. We need a database, which is like the overall database, the entity, which is kind of like the table, and then the DAO, which is the way that we're going to access stuff in there. So I think DAO means data accessor object, or database accessor object. But let's first look at the entity. This is going to represent what we want to store in the database. So inside of here, so the design of this database is not the best one in the way that it uses a string as the ID and the label, but it's just kind of what I had in my sample data in this app and I rolled with it. But that being said, label is our primary key. And what's nice is, I hated on Room a while ago because they had only Kotlin vars that you could do in here, and I really like immutable data. However, in the latest versions, they have changed over to use nice Kotlin vals, and it's a lot better. So you slap this entity annotation on a data class. You can describe something like this label being the primary key, and then other properties that may be there, like a non-null string, a nullable string, or a long. And then if we look at our DAO is an interface that we slap on a DAO annotation to. And each one of these things like kind of correspond to what we had previously in our shopping cart, like implementation that we had in our app. So in here, you do end up kind of writing SQL. I'm saying slap on our app, but yeah, you end up putting on a query annotation and you say what the query is you want to be run. It's kind of nice because as you mess with stuff in here, like you'll see errors as you're doing it, so you don't have to actually wait for it to compile. So it's kind of nice how they've done that a little bit. But you still have to write a little bit of SQL in here. In this case here for this upsert, I'm just doing an on conflict replace. So what that means is go ahead and add the item in the database, but if it's already there, like just throw it on again. And in this case, like you're finding by label where you're querying. So anyway, this is the way that we're going to implement it in Room. And then finally, there's the database, which is really bare bones, but it's saying that this database contains these tables essentially. The item and cart database, and it's a version 1, and this is the way I grab it. So and when I go ahead and access it at runtime, it'll be this DAO that I interact with. So what does a generated code look like? So you saw, this is actually a really not a horrible experience. It's actually pretty nice. I just put on some annotations. I put some nice queries in here, and you know, Room works. But what does the generated code look like? So there's two classes that are generated. This one is the implementation of this thing. So the Room item and cart DAO. So inside of here, it's kind of dirty, but you can see like this is our constructor. It's going ahead and do the create query for this table to go ahead and make sure it's there. Then we kind of go down, and then you finally see things like override. So this is that interface we had before doing the upsert, which is the insert or update. And so it's kind of going through and doing stuff. The removal, the empty, the select all, which this is that, the select star from Room entity is exactly what you're seeing here. So it's going ahead and bringing that into the generated code. Then it goes through cursors and things. And you can go down here and like find by label. So it's not bad, but like you look at this and it's generated code. It works. And then secondly, we have our database implementation. And this is really responsible for actually creating the database tables if they don't exist. So you have the create statements in there, the drop statements, and the ability to like connect to that database. So the code generated from annotations is nice. Like you just slap on a few of these annotations, you generate deterministic code. But like I really don't like that it can break incremental builds, but they are fixing that. So, you know, it's getting better. All right, so let's check out the session graph now. And thankfully we fixed that compilation error because we're going to be running some code. So inside of here, this is like pretty simple interface, but I've actually set this up now where we have 3 database types: in-memory, Room, and SqlDelight. So right now in-memory is being used. I'm just going to go ahead and switch this to Room. And then when I run it, it's going to be using that implementation. Now this isn't like the best way to do this, but I did this here so that we could easily swap between them. Let's see. All right. And then, yeah, we have 5 items in the cart now in the in-memory version, but when it runs, we have 0, right? So let's go ahead and add a few items again, like some pineapples, make it a little tropical, and then add some flowers. So there we go. We go to our shopping cart, and everything's there. Now, we wrote a database, right? Let's make sure this thing works. Let's kill the app. Let's open it again. All right, room worked. Congratulations. But did it work? How is it working? Like, there's a database. What does that database look like? What's going on? I don't know. So one thing that I'm really big into is how did that thing work? What's going on? That's why I'm showing you the generated code. I also want to show you, like, it's not just like this data stored somewhere. Let's see where it's stored. I love debugging features. I was actually inspired by Matt Precious's talk at droidCon Montreal, where he went into debug features. But I did this talk at droidCon Boston 3-4 years ago or something, just about building debug features. And when I was stumbling around, I didn't know about this library, and so I want people to know about it. It's called Android Debug Database, and it's really useful to see what's inside of a database. The setup instructions are on their GitHub page. It's really simple, but it looks complicated. Let's not worry about it too much. Let's kind of just see it in action. So I have it already open in my web browser here, and it's like TCP'd into my emulator, right? So it's like, it's doing port forwarding to allow me to like request something to my local computer, which is running a server on there, and then they're like grabbing stuff in the database. So it's this kind of magical thing, but what's nice is I can now see everything in my shared preferences. So you can see app shared preferences here. Things that I already stored was like the current user, Sam Edwards. I just typed some random garbage for the last username, and remember me is enabled. I do have Chuck up here, which is a debugging library for HTTP traffic. So you can see in this that it stored all of my HTTP traffic for the login, and as we went along, it'll like the categories that I requested, it'll have all that data there. So it's nice that you can see that. But the room database is really what we want. So we can look at that in our entities, and there it is. So we can actually see inside the database that's on the machine, and we can validate that everything was stored correctly. So we have 3 pineapples and 2 white roses. And if we look over here in a second, we can see that's the case. What's really nice about this too is you can just look at it, but you can actually change things as well. So I could, like, for instance, change the image and change the quantity here, save changes, come back, and then it's not automatically reflected, but as soon as I change it, it'll read from the database again, and then never gonna give you up, never gonna let you down. I don't know, I saw that Steve Ballmer thing the other day that came out when they released Windows 95, and anyway, you got rickrolled. So that's nice that you can actually modify this stuff in your database, and your app can immediately reflect those updates. So this tool is something that if you just walk away from this talk, you didn't learn anything, I like this a lot. And it's available on GitHub. So testing Room. So we talked about Room, we got Room working, we see it works, but let's try to test it. So one thing that I didn't like about Room is that all unit tests must be run on an Android device. There's some documentation for how to do that. What's nice though is it can be run without the UI. You don't have to launch a whole activity. You can just run like an application test or instrumentation test and do it there. And you could run it. If you did, we saw that 200 milliseconds is how long it took when you did the in-memory version. This took 4.4 seconds, and that's because it took longer to run on an Android device. If we looked at that test that ran in 4.4 seconds, it really looks no different than the one that we wrote for the in-memory version. It probably looks exactly the same, and that's because we're using this test delegate method where it just has this happy path, 300, and so forth. But if you go into the test delegate, this is like the implementation behind it, where it's saying, I want to use a shopping cart that's backed by this Room shopping cart DAO that, in this case, uses an in-memory database builder. So you want to use this in a test because as each test runs, you don't want all this data stored on the device and then have to clear it. If you use an in-memory version of Room like you can here for tests, then every test you run will get a fresh version of Room. That being said, you still have to pass in a context, and that's because it's running on the Android device and has to. But pretty cool, we can test Room. Now, SqlDelight, let's get into that. So SqlDelight was written by Square. As a version 1.0, at Kotlin Conf last year, they talked about it, Jake and Alec. But as a version 1.0, it completely generates Kotlin code. And so that was really cool, and another reason why I looked into it. So this was released in January. I looked into things in February, kind of got to see what's going on. The changelog, which you probably can't read, is up on the right, is for the latest version that was released in July. That has experimental support for Flow and a lot of other stuff that keeps getting incremented on. So we talked about that it generates Kotlin code. SqlDelight has actually been around a long time. I was watching one of Alex talk from 2016 or whatever about SqlDelight, because it's had a lot of iterations. So it's not something that just kind of came out of nowhere. That's all I'm trying to say. It does incremental. This is really interesting because I talked about incremental builds and breaking them, and it does incremental builds because it does not use annotation processing. It does not use capped. So most of the libraries you do that do code generation take the annotation you added on, it runs through the annotation processor and spits it out. This actually just, you write a SQL file, and then it generates code from that. So we'll kind of see what that looks like. Another thing, which, again, this is a whole talk I could do, is this supports Kotlin Multi-platform. So if I go ahead and use SqlDelight, I can actually use this on iOS and Android, and that's really cool. But for me, like Kotlin Multi-platform is still like it's not there yet for me. Like I haven't had the time to dive in, and so I know it's there, and that makes me really happy that I could go to Kotlin Multi-platform and I already have something that works on iOS. So that's a big benefit. So the setup is similar in the way that you have just two things. You need your runtime dependency, and then you need your implementation dependency. Or sorry, your Gradle plugin implementation. So let's check that out. So we'll look in the SqlDelight version. And in here, there's three things. One is the SqlDelight Android runtime. So when you run on Android, you need this driver for SqlDelight. And then when you run on the JVM, you need another one. And then one other thing is you need this plugin. So don't worry about taking notes on this one too much. The blog post I wrote goes really into how to set this up. But you have to apply this Gradle plugin, SqlDelight, and that's because it's going to go ahead and look for any SQL files you have and generate code from that, which is like this different way of doing it. All right. So we looked at the build Gradle file. So let's look at the actual SQL that we wrote for this. So this is the SQL that we pretty much had in our room stuff as well, but in this case with SqlDelight, you write all the SQL up front where you have to actually write the create statement that's going to say like, create a label that's non-null with a unique primary key. The select all function here that gets generated is there. Insert or replaced is backed by this SQL. Select by label is backed by this SQL. And at the end of the day, you get code generated off this that we'll check out now. I think we've already talked about how the code generation works, but I'm going to hop right into what's generated. So we see here that like this item and cart, we've described 4 properties on that database. The primary key, some defaults, and other things there. Oops. So if I jump in here, this is code generated by SqlDelight. It has an interface for item and cart, which has those 4 properties, and then it has a data implementation backing that, which just has a toString. The next thing that it generates is queries. So this is the thing I kind of wanted to jump to real quick. You never get these things perfect. But if you look at this here, you have your create statement, and then you have all your queries below. So you have select all, insert or replace, select by label, and that's pretty much exactly what you're seeing here. So you're seeing select all, select by label, insert or replace, empty. So from this SQL file, they generated this code. So it's super easy to kind of see like what this transaction is doing and what this is represented at in the code. So pretty clean. Then you have your actual database implementation. So in here, you're actually, let's see here. Put it out. Yeah, you're actually going ahead and having the database, and sort of inside of here, you have that same create statement that you had in your SQL. So the reason this works for Kotlin Multi-platform is the fact that this SQL code that you see written here is actually the same exact code that you went ahead and wrote here. There's literally, I don't know if I could do like a find, but it's exactly the same thing that you see sitting there. So that's the way it works, is you've already written your SQL databases use that. So like if you can kind of wrap that around code that executes it and create like a type-safe way of interacting with it, that's all you need to do. So yeah, you went through, you could see more stuff like the select statement here is pretty much the same thing for the select all. The insert or replace. This looks pretty much exactly like it did in the SQL file. It's just kind of wrapped in code to make it work. So let's run SqlDelight now. And all we do, because it's easy enough, we say SqlDelight here and run. So as we saw here, yeah, we have these 3 databases already. We should see SqlDelight pop up on here after it runs. And we should have no items in our cart because we're using a database, new database now. All right, we have no items in our cart. If we look over here in our debug database tool, we'll see now that we have a cart SqlDelight. And in this table that we've created, item in cart, there's nothing in there. So let's add a few things. For some reason, I'm liking pineapples today. Get another apple. And then look in our cart, and there it is. So if I come over here, I can actually just like kind of click around to refresh. And now you can see in the SqlDelight database, I have my 3 pineapples and 3 red delicious apples. Yeah, can kind of go through and just see that reflect. So as you see, like this is another way, like I want to see that this is actually working, right? Even if it's saved, like what's in my database. And yeah, the one thing if you walk out of here, make sure that you like check out this tool if you're using a database, because you can really see what's going on. Right, next slide. All right, so I just showed you it worked. That was important. I wanted to make sure that you saw that. Now unit testing. This was kind of like a thing that pushed me over the edge and like kind of leaned me to like say that this is important. So incremental builds are super important, and testing off an Android device are really important. So SqlDelight provides a JVM driver that works on any Java virtual machine. So your laptop, your CI server, it doesn't have to run on an Android device. And if I ran it here, it ran in 600 milliseconds. So in-memory version ran in 200, SqlDelight version ran in 600, and 4,400 if you did it in milliseconds for the room implementation. And that's because it just takes longer to run on Android. If you wanted to look at that, it really looks exactly the same as everything else. And that's just, I wanted something that I could compare that wouldn't be biased. So let's see, that's my delegate, and then my test should be right next to that. So yeah, here's my test. It looks exactly like everything else. It's just this test delegate that I'm using to actually go ahead and run the stuff with. I just swapped out the actual shopping cart to be a SqlDelight shopping cart. And what's different here is the SQL driver that I'm passing in is not an Android SQL driver. It's a JDBC-Lite SQL driver that's in memory. If we looked back at our session graph, where we actually created the Android version, when we created that SQLite Android version, we're passing in the Android SQLite driver. So with SQLite, you pass in a driver, and that's kind of how they're able to switch out like what's underneath the hood. Cool. So like I said, Kotlin Multi-platform is really cool. I've seen some talks here, and I'm really excited about it, but I haven't gone there yet. And I bet like a lot of you haven't, you've heard about it. And the thing I'm hoping from this talk is you're seeing through the eyes of just a Kotlin developer, like I want to write a database on Android. I don't know anything about multi-platform yet, but I like, what do these libraries do? What does the generated code look like? How does it affect me? And I want you to kind of walk away with that. So we got a little bit more here. Now the secret here is there's no magic behind either one of these libraries. Both of them, when they actually run on Android, use the Android X support SQLite database. And the way they described it on their documentation for Android X is a database abstraction which removes framework dependency and allows you to swap underlying SQL versions. So they've created this, and what's happening is, and these are slides that I pulled from the Kotlin Conf talk they did last year for SqlDelight, but there's this Android X abstraction here. And this is what everything's talking to. Room's talking to it, SQLite's talking to it, but like behind that, you can add extra things in the implementation. So typically you'd use this top path where you just write to the database, but if you want to, you can actually put something else that like uses SQL cipher or something to encrypt your stuff. So you have the ability to kind of swap out the implementation that's writing to disk, but always you're writing to that like interface abstraction from Android X. If we zoom out a little bit, then we could see this is the Android driver on top of this, right? So this is the Android code that we're writing that interacts with this Android X API that goes in, because the Android X API isn't what we use in Room, it's like the level below that. The Android driver itself is Room or SqlDelight, right? So it's that Android implementation for both. But we step back further, SqlDelight is actually this abstraction on top of Android. So the reason why is it could be used between multi-platform, it can be used in JDBC to correct over JVM, or on Android, or even on C++ here. So what's kind of cool is the way we wrote our unit test is that SqlDelight JDBC driver allows me to do everything in memory and do it on the JVM. So the moment you've been waiting for, the winner is, it depends. This is a blog post I wrote a while ago too. It depends is the answer to most questions. But in the blog post it talks about it depends is a shitty answer, right? So let's give you a little bit of context. So I'm going to try to compare them a little bit side by side and some of the main points that I thought of when I was evaluating them. Both of them use the support SQLite database. So under the hood, they're both using the same thing to kind of like interact with the Android database. There's nothing magical there. They're just kind of ways on top of it that we're able to write code. One's maintained by Google, other one's maintained by people at Square. In Room, you're writing those annotations that use Kotlin annotation processing to generate code. In SqlDelight, you have this Gradle plugin that you write your own SQL, it generates code from that. Now, as you saw in the generated code, I'm going to lean the way towards SqlDelight. It seems to be a little bit nicer. I could super read that code. I wrote my SQL, and I didn't talk about this too much, but writing SQL is, as an Android developer, is kind of hard. Like, I don't necessarily know SQL, right? Like, it's not part of my job title. So I think one thing that's lacking now is, for SqlDelight, is how do I know I'm writing good SQL? Where do I get that? So I know there's a lot of resources out there for like other developers, for backend systems and so forth, but I don't know what that looks like from an Android perspective. So I'm hoping that we can find that. It is kind of nice when you use the annotations, because if I'm a new Android developer that's used annotations on like Retrofit or something else, I just put these annotations on my code and then it just kind of works, right? So there's not much you have to do there. There's a little SQL you write in, but if you're doing something really basic, Room is super approachable, right? Jetpack is supposed to be something approachable that scales, and I think they did a good job there. But when you talk about long-term, if you write something in SQL and you need to do migrations and you need to support it long-term and you need to understand complex things, relationships between things, then when you get down in the SQL, it's like this upfront complexity that will pay off. So it's kind of the lens you're looking through that I feel like Room is better if you know annotations, you want something working. And the good news is they're both using that same SQLite database. So you could switch between the two as long as you match the schema. It'd probably be difficult, but you can. Like I talked about, we did the annotation processing versus the SQL. So this is a big thing. Room has great documentation. And then SqlDelight, not so much. The thing I'm finding though is, as I talk to a lot of people, they are playing with SqlDelight, or some of them use them in production. So it's one of those things where even like Kotlin Multi-platform now, it's like, okay, it's there, but like there's not that much great documentation. I don't know how to get up and get started. That was one of the reasons why I wrote that blog post last week. And I'm hoping that it'll get people into SqlDelight, but we still need that information about how do I write good SQL and things of that nature. The clean generated code, I like that. A little bit hard with Room. And thing is, if you're going into production, Room right now is like super tried and tested, right? It's been in like hundreds of, I don't know, thousands of apps. And SqlDelight, I'm saying not widely adopted yet, although I keep talking to people that are trying it out or using it. So like, I think we're maybe at this inflection point, right? Like, we need more data, we need more people to like, you know, create documentation and to be saying that they're using it and sharing it. I think though, when I look at it from the perspective of, I'm doing this feature long-term, I'm running a database, like, I know I'm gonna have to deal with SQL at some point, and the code looks so much cleaner, and I can do Kotlin Multi-platform, so I'm leaning the way towards SqlDelight. But Room does everything well, you know, as well. So you kind of saw, they both do the same things, but both are a little bit different. The big seller, if not for anything, is the JVM test, right? The ability to write code that runs just on a unit test off an Android device is super important for me. I love quick turnaround times and continuous integration servers. I don't want to boot up a continuous integration server if I don't want to. So that's really big. So anyway, both great libraries. It depends, but I tried to give you not a shitty answer. The end. All right.